We humans are very good at estimating those things that we have already done. So if we're repeating something, if we're doing it again, we can work out roughly how long it's going to take. But it's interesting, when we don't have all the information, we are notoriously bad at estimating how long things are going to take, how much things are going to cost, how much effort things are going to be. And according to some research, we can be a factor of 4 out from our estimate at the beginning of a process. So if we think it's going to take 1, it could take anything from a quarter all the way up to 4. That, of course, is incredibly ambiguous, very, very uncertain, very difficult then to know what to do with, because how do we estimate anything? As we know with Agile, what we're looking to do is to, when we don't know anything, when there is uncertainty, we run experiments, we test hypotheses. And so what we do with Agile is we try and put an estimate on things so that we can then learn from that. So we estimate, we then learn from that, and then we can start to refine our estimation as we go forward. I'll give you an example of this. How heavy is an elephant? Well, unless you know that for sure, or this particular elephant, unless you've measured it, you won't really know. You could kind of guess, I suppose, but again, likely we'll be out unless we know, we have the information, we'll be out by a factor. But one thing we can be reasonably sure of is that we do know that the elephant is lighter than this blue whale. I presume it's a blue whale. Anyway, it's a whale. But we can see that it's going to be lighter. So we can say, right, well, we know that once we've figured out how long it takes to, for example, clean the elephant, knowing that it will take longer to clean the whale, and we can introduce other animals from the animal kingdom and say that we could put these in order, and we could say that one is smaller than the next, and we are very, very good at what we call relative estimation. So we would have probably little problem putting these into the right sequence, from smallest or heaviest to lightest as we go. Question always is, how long will something take? And just recently, following the storms, we had to re-roof a couple of sheds. And the question is, how long is it going to take? And we didn't know. What we did know was that one shed was bigger than the other one. So we kind of thought that the first shed, the bigger one, would take longer than the second shed. So that was our estimate. Again, with Agile, you need to be quite flexible, because when we moved into it and started uncovering things, we found out there was more complexity with the smaller shed. And so, as it turned out, both sheds took about the same amount of time, because we're actually doing different things to get there. So we're very bad at estimating how long things will take unless we've done it before. So what we do to use to make our estimates is, I prefer to use a Fibonacci sequence. So the Fibonacci sequence there, 1, 2, 3, 5, 8. The way it works is the next number is the sum of the previous 2 numbers, is how it grows. And we're not saying that 2 is twice as big as 1. We're just saying that it's bigger than 1. If we don't want to use numbers, a lot of people use t-shirt sizing. So they will say that something is small, medium, large, extra large, and they will basically put their estimates on that if they don't want to put any numbers to it, to work out which are the bigger things and put things in order. And then other people like to play with things. As you can see here, they've decided that one thing is a skateboard all the way up to a space shuttle. And so you can try and estimate what you're doing with that. So however you want to do it is fine. Personally, I like the Fibonacci sequence because I like the numbers, because I like to be able to use the numbers later. So let's take an example, and this is how it was taught to me. If we were needing to build this particular item, we could try and do the whole thing all in one go, but we have no idea. We've never done this before. We have no idea how to do that. So what we want to do is break it down. So is there something which is the smallest part that we could estimate on? And for example, here we'll say that railing is probably the smallest item. And we'd give that an estimate. We'd probably say that it was a 1 or maybe a 2. Because that's the smallest item. And then everything else around around what we're building would then be in relation to that. So for example, the stairs here would be somewhere between a 3 and a 5, and maybe the base we would say would be about an 8. and then the rest of the rest of the cabin there, we're not sure how much that will be, so we're going to give it a 21 points. We're just going to put that out, park it for a second, and let's say we can do 16 points in a sprint in a period of time that we're going to do the work. So we probably know that we could build most of that apart from the big 21 pointer. How do we actually go about deciding what points to use? And every team is going to be different, and every team would allocate different points to the thing. Once a team has been working for 2 or 3 sprints, they will get very good at estimating the relative effort in creating something, and they will know how each other work. But to start with, what we like to use is something like this. We call it planning poker, and what you do is you have a series of cards, and each individual has their own set, and what we do is we look at the thing. For example, the ramp, we discuss the ramp, and then every person selects from their cards and puts a card on the table to say how long, what the effort is that they expect that to take. And there is an option to say we need to discuss it further, which would then be that one there. You use that one to say we want to discuss this further. Another way to do this, you don't need the cards. There are options online that you can use, or you can just use your fingers and vote with that. The way we do this is that if everyone agrees on the number of points, that's the number of points that we're going to start with. If there is a disagreement, what we do is we have a conversation. We don't discount the people who pick a number which is way out of an outlier. Those are the ones that we actually want to have a conversation about. We want to understand why that person thinks that what we thought was a 2 is actually an 8. So we have that discussion and then vote again and see where we get to. But the idea is just to give us an idea of how long these things are going to take. Then we start working and we start building whatever it is that we're doing. We find then that actually something takes longer than we anticipated. We then mark that down, but going forwards, if we're ever going to do this again, we know how long that took. Okay, so that's how you do things. The 21 pointer, by the way, you break that down. You don't deliver that first because it probably, in this example, it has slightly less value. And so what was that? And so what we do is we say, okay, how do we break this down? And now, based on the information that we have from having built the first part, although this is very different again, we are now feeling more confident because we're working as a team. We know each other, we know what we're thinking, and we can then start to allocate points. It may be somewhere between 8 and 13 to deliver that piece of work there. And again, we refine our estimates as we go. Now, the first 2 or 3 sprints, as I said, is going to be a bit difficult to really estimate clearly where we're going to be. If we've got a big project and let's say we're delivering a total of, say, over 100 points or 200 points worth of effort, we're not sure exactly where things are going to be. But what we can do is we can take that information and start to plot it. So as we are delivering items, we can say, okay, over the first sprint there, we delivered very, very little. By the time we got to about sprint 8, we had delivered 40 points worth of effort. But sort of from sprint 3 onwards, we can start to gauge this. And then what we do is we can start to estimate where we're going to be. So based on that, the cumulative points, we know what the worst case scenario and the most likely best case scenario is going to be for us to deliver this entire project of 200 points. This means that if someone says, could you tell me what you will have delivered by the end of sprint, say 25, we can say, yes, it will be somewhere between these 2 points. Again, now that's quite a wide range, and we sometimes that's too wide a range for us to do anything with. If that is the case, but at least we have information now. We have data, we know what our velocity is, we know what it is that we're trying to accomplish, and what we may then do is reprioritize the product backlog so that we can deliver whatever it is that we want to deliver earlier, if that is the case. We can also look at saying, when are we likely to deliver a particular item? Let's say the item that relates to point 110 in the product backlog, we can say that we know that's going to be delivered somewhere around sprint 16 to sprint, 27. So we know that it's somewhere within that range that it's going to be delivered. Again, if that's too wide a range, we then can do things to the product backlog, but we can start to estimate when things are going to be delivered. The other thing that is important to note is that as we get more data, we can refine our estimates. And so let's say that a couple of sprints later, what we know is that that sort of profile has been happening. So, okay, good. What we can then do is we can say now our best and worst case are likely to be a much narrower, across a much narrower range. So what we then do is we say, asking the same question, what can be delivered by sprint 25? Now we know that we are more likely to deliver between those 2 points, as opposed to the 2 points that we had before. And we also know when we're going to deliver a particular thing to within, in this case, to within the margin of a sprint. And again, just to show you there the numbers that we had before. So sprint planning, it's a lot of fun. We don't want to get too caught up in it because we want to learn as fast as possible. Do not spend too much time trying to work out in great detail, great minutiae, what the points are going to be. Because again, for the first 2 to 3 sprints, we won't know for sure until we start moving. But again, we want to put an estimate down. We want a hypothesis that we can measure against so that we can learn, get feedback, and work out how long things are going to take. Obviously, for the next project or the next item, things are going to get easier because now we know how we feel about the work that we're doing, and we know each other, and we know how each other's strengths and weaknesses. Hope that helps a little bit. There's lots of great material on this that you can find online, and in some great books. And I'll put some posts, I'll put some recommendations in the text below.